In many real-world scenarios, we'll probably be required to create a graph that takes something more than trivial floating point value or other scalar value as an input. Oftentimes, we'll probably be required to take something like an external polygon mesh or a spline object or other things like that. So in this tutorial, I wanted to introduce ourselves to the notion of using an external scene object as an input to our graph. So let's start out by creating a sphere, and we'll just create a box. Our sphere is going to be the distribution object, and the box is going to be our proxy object. And what I wanted to do in this video is basically take this box and spread it all over the sphere. So I want to basically clone it for every single vertex on this sphere. So to start, let's go into the Modify panel and throw our geometry modifier on it, which is a lab plugin, and then I'm going to edit plugin to begin editing the plugin. So now if we go into the hidden inputs and select my input, I'm just going to drag it out to make it visible. I will right click. Right now the type for this input is system.single, which is a floating point value, and instead we will change it to polygon mesh. Once we do that, you can see that inside the user interface our input has actually become a button which can now pick our box. So if we select a box like this, we can pick it for this input. So now we have essentially two inputs. We have our mesh input and our box input. We will use our mesh as the distribution object. So let's drag it out, and this will create a type value node from which we can use its vertices. We will now need to create a subgraph which will, for every vertex, create a version of this box object, but which will also place this box object over that vertex. So I'm going to go and type graph to create a subgraph, and then I'm going to double click to go inside the graph. And as the inputs for the graph, we want to have, first of all, we need our mesh, so I'm going to add our mesh input, and then we also need a position, which is where this mesh will be positioned over. This mesh I need to set to be a polygon mesh, and the position is going to be a vector 3 value, so it's a 3D vector value. So I can drag out the mesh to create again a type value node, and it's going to give me our vertices and polygons. And as the output, we also want to have a single mesh, so I'm going to create polygon mesh just like this, and we're not going to be changing the topology of our mesh, so we just can simply take the polygons and we can pipe them into our result directly, and this will be our result. So I can just drag this in here. For vertices, what we want to do is take every single vertex in this reference mesh inside the box and multiply it by a matrix which is positioned over the vertex that is passed in, over the position of the original mesh. So this sounds complicated, but it's actually a lot simpler than what it is. First of all, what I want to do is I want to create an xform3. And xform3 is a class that is responsible for doing 3D transformations, which includes rotations and positions. But in our case, we're just interested in having a position. We're not interested in rotation. So I will use xform3.createTranslation. And what this will do is this takes a vector 3 value and it creates a translation matrix out of it, which then translates any point on top of this vector 3 value. So I'm going to take our position and I'm going to drag it into the translation value. This says positions, but we're really taking a single vector 3, so I'm going to change it to position. So now we have our matrix, and we can now multiply it by every single value in our box mesh. To do this, I'm going to add multiply, and this time I'm going to use multiply alternative 2, and the difference between alternative and alternative 2 is the output that it produces. In this case, the output is going to be the same type as the second value. In the first multiply alternative version, it actually produced an output which is the same type as the first value. So the reason we want to do this is because first operand into the multiply operator has to be our transforms. Transforms in our case go first, and the vertices that we're going to transform go second. And as a result, we get our vector 3 array, which is every single vertex in this mesh multiplied by this transform. And I'm just going to pipe this into the vertices over polygon mesh. And we're done with this graph. So basically, we are doing a simple transformation for each vertex in our box mesh. So on the outside of this graph, For every position, we want to specify our vertices in the distribution mesh, which in this case is a sphere. So I'm going to drag this out and put it into positions. And as a mesh, we want to specify our box mesh, which is my input over here. And I'm just going to rename it as our cloned mesh because we are cloning it over each vertex. And now this graph will produce an array of polygon meshes. And what we need to do now is we want to take an array of polygon meshes and kind of combine, or we want to merge them all into one polygon mesh. And there is a special operator for that called combine. And it is part of polygon mesh extensions inside the Ephere geometry class. And if I create this combine node, as you see, it accepts a collection of meshes, which I'm able to provide, because our graph takes an array of positions and then as a result outputs an array of polygon meshes. And as the output, I can just wire this directly into the result of our plugin. So when I do that, voila, we get our nice sphere filled with boxes. And if I go to the sphere now and I start modifying the size of it, or if I change the number of segments, we can see that it changes, as well as the box. I can go to the box and I can change the dimensions of our box, and we can see that the box is actually now positioned over every single vertex of the sphere. Let's save our scene so we can reuse it in the future tutorials. I will save this as cloned meshes. And in the future, I want to introduce more interesting ways of distributing our box on top of our sphere rather than just using the vertices. But more on that later.